Hi there. Today I want to talk about the overall reaction in which 1p-LSD gets bioconverted into LSD via hydrolysis or deacylation. The structure for 1p-LSD. This mechanism occurs inside of a serine hydrolase enzyme via water. This is a nucleophilic acyl substitution reaction in which we basically cleave off that propionyl group. Mechanism for nucleophilic acyl substitution of the propionyl carbon is as follows. This is the active site of the enzyme that we're talking about, a serine hydrolase. First step is for a lone pair of electrons on histidine to grab a hydrogen off of serine, thrusting the electrons between the O and the H onto the O as a lone pair of electrons, making it O-. Here's the structure of that chemical intermediate that we just went over, the NH+ and the O-. The next step for the mechanism is for 1p-LSD to move into the active site of the enzyme. In this step, a negatively charged serine will act like a nucleophile attacking the C-double-bond-O bond of the amide, pushing the electrons onto oxygen. We then have a proton transfer to the indole nitrogen. The nitrogen will grab a hydrogen off of histidine, thrusting the electrons between the NH onto the N as a lone pair of electrons. And that'll transfer the hydrogen to 1p-LSD. Here's the tetrahedral intermediate that we just talked about generating. Tetrahedral intermediate will go away, by which the negative charge in the oxygen will collapse to form a C-double-bond-O. The bond between the N and the C will then collapse or break, releasing LSD. There's the released LSD, but in enzymology, the enzyme needs to regenerate back to its original structure. Water moves into the active site now. One pair of electrons in the nitrogen will attack a hydrogen on the water molecule. That'll basically give us OH- to generate the nucleophile, and a protonated histidine. We then have a nucleophilic attack of the C-double-bond-O by the OH- of the deprotonated water molecule. OH- will attack the C-double-bond-O bond. The pi electrons will go onto the oxygen. We'll then have a histidine proton transfer to serine. Serine will grab the hydrogen off of histidine. Electrons will collapse on the nitrogen as a lone pair. And lastly, the tetrahedral intermediate will collapse to release propionylic acid. One pair of electrons in the oxygen will reform the C-double-bond-O. The bond between the C and the O will break, go onto the oxygen as one pair of electrons, neutrally charging it as propionate or propionylic acid. That is our mechanism. Hope you enjoyed that mechanistic video. Bye-bye.